The first quantitative measurement of force of electrical attraction or electrical repulsion was done in the year 1785 by a French physicist, Charles Augustin de Coulomb. Before the year 1785, many scientists knew that there is electrical attraction and electrical repulsion when two charges are brought near. But quantitative measurement of the force was only possible in the year 1785 when Coulomb gave his law. Coulomb used two small metallic spheres with the charges Qn and Q2. Students, I just want you to go and check your book once and find out how Coulomb got the values of Q1 and Q2, the charges. It is an interesting story, and it is very scientific how he approached charges on the metallic spheres. For now, let the charges be Q1 and Q2. Q1 is the quantity of charge on the sphere 1 and Q2 is the quantity of charge on sphere 2. Coulomb found that the force of electric attraction or electric repulsion is directly proportional to the product of the charges, and he also found that the force of attraction or of repulsion is inversely proportional to r square. R is the distance between these two charges. Another important thing what he found was the force of attraction or of repulsion acts along the line joining the two charges. So this is the line joining the two charges, and force will act only along this line. It means, suppose sphere 1 with charge Q1 experiences a force due to charge Q2. So this charge or this sphere will experience a force either attractive or repulsive. Repulsive means going away from charge Q2, and attractive means coming towards charge Q2. So this force, this nature of force, attractive or repulsive, depends upon the type of charges. That is, if Q1 is positive and Q2 is also positive, then these are the like charges, then repulsion will happen and Q1 will be pushed outward. So what is this? Most important here, the pushed outward thing will be, this force of pushing it outward will only be along the line joining the two charges. So there's a line joining these two charges, and the force will act only this line, along this line. And even if the one charge is positive and another one is negative, that is unlike charges, in this case attraction happens. So Q1 will be pulled towards Q2, but along the line joining the two charges. So now coming back to Coulomb's law, F is equal to K into Q1 Q2 upon R square. This comes when we combine these two equations, and K is the constant of proportionality, and the value of K is 1 upon 4 pi epsilon naught, and it is equal to 9.0 into 10 to the power 9 Newton meter square upon Coulomb square. Epsilon is the permittivity constant. Its value is 8.85418 into 10 to the power minus 12 Coulomb square upon Newton meter square. To know more about the permittivity constant epsilon naught, we'll do it when we'll be doing capacitance. Students, since force is a vector quantity, so now we have to come to find the vector form of Coulomb's law, and we will derive this now. And why there is a need to derive this, we'll talk about that also. First, F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square is the formula for force. What I told you about the direction of the force is the direction is along the line joining the two charges. So for two charges system, it is very easy to find out the direction. The force experienced by Q1 due to Q2 can have two directions. The force experienced by Q1, if it is attractive, will be in this direction, and if it is repulsive, will be in this direction. Only two possible directions are there because force should be along the line joining the two charges, and the directions will only along the line joining the two charges. But if the number of charges are more than 2, suppose there is a charge Q1 and there are another charges here Q2, Q3, Q4. Now the force experienced by Q1 because of all the other charge will have many lines joining the charges like this line. So if we find the force experienced by Q1 due to Q4, then the line joining these two charges will give force. Again, if we talk about Q3, then we will have this line. These many lines means the forces will be along these lines. So force because of Q4 can be in this direction, or if it is attractive, it will be pulled towards Q4. If we talk about force due to Q2, it will have these two directions. And if we talk about force due to Q3, it will have these two directions. These many directions are there, and that's why we need a vector form for Coulomb's law. With the help of vector addition, we can easily find the resultant force. So now let's derive the vector form of Coulomb's law. To understand the vector form of Coulomb's law, the first thing you have to do is set up a reference frame. So a reference frame is set up, and this is the x-axis. Now what we are doing here is we have set up a reference frame with an origin at O, and the positions of these two charges are given by R1, and we'll give an arrow over it, and R2. These are the positions. What is required when we talk about F is equal to Q1 Q2 upon R square? Q1 and Q2 is already here, the charges are given. K is a constant of proportionality, which is also we know. What we don't know here now is R, and R is equal to the distance between Q1 and Q2. Now when we talk about force experienced by first charge Q1 due to charge Q2, so we write it in this form, F12. Alright, to find this, what all we have to do is we have to find R12. R12 is the displacement between these two positions, which is R1 minus R2. So force on 1, force experienced by 1 due to Q2 can have either this direction, the force can be repulsive, or can have an attractive force. This Q1 can experience either a repulsive force or attractive force. So F12 is equal to constant of proportionality, which is 1 upon 4 pi epsilon naught into Q1 Q2, the product of charges, by R12 square. Why we have put mod? Because mod will give only the magnitude of this displacement. This is what we need actually. We need just the distance. And since r12 is a vector quantity, it gives direction also. We don't need direction here. For that, we'll be using something else which is called the unit vector. Now we can write r12 cap, which is unit vector. r12 cap is r12, the vector r12 by mod of r1. Let us understand what is vector r12, which is actually equal to r1 minus r2. We will use a diagram to understand it. Already we have seen here in this diagram that what is the direction of r1. r1 is from origin, it is going like this, and r2 is somewhat like this. Now vector addition says, what do we do to find the resultant? That we join either head and head or tail or tail. So we have joined tail and tail, and addition will be somewhere in between r1 and r2. So this is r1 plus r2, but this is actually a diagonal of a parallelogram. If we know the parallelogram law of addition per vector, then it will be very easy to understand. Now what we have to do, r1 minus r2. So to find r1 minus r2, what all we have to do, this is positive r2. We just have to find minus r2, which is just opposite of this direction. Alright. And when we join and when we try to form a parallelogram here, then this resultant will be r1 minus r2. This portion, this vector is r1 equal to this r1, and this is minus r2, and this is also minus r2. We are meeting the tail of minus r2 and r1, and this will be r1 minus r2. So r1 minus r2 is actually r1 plus minus r2, and we have used the parallelogram law. And finally this is the resultant. What we have seen here, the resultant force. So this is giving, this unit vector is r12 is giving the direction for the force F12, and this is the universal formula for finding the force between two charges. How this is universal? Let me tell you. If Q1 into Q2 is positive, it means both the signs, both the charges are of equal sign, like charges, either negative negative and positive positive. If it is negative negative also, the product will be positive, and if it is positive positive, the product will be positive, and which is greater than 0. If Q1 into Q2 is greater than 0, it means we don't have to change the direction of R12, which is repelling R12 is going away from charge Q2. And if Q1, Q2 is less than 0, then what will happen? It will give a negative sign for product of Q1, Q2. So whole this F12 will have a negative value of whatever value we have found here, that is 1 upon 4 pi epsilon naught into Q1, Q2 upon R square. So if Q1, Q2 is less than 0, the direction of the force will be opposite of what is the direction of R12, which is, like if we see the screen, it is going away from charge Q2. So in this case the direction will be negative of what is the given direction. So negative of this direction will be almost opposite this, and this is one attractive force because of the unlike charges. And by this we know the direction of the force F12. In the students, that's why F12 is equal to minus F21. F12 is force experienced by 1 due to charge Q, and F21 is force experienced by 2 due to Q1. These forces have same magnitude but opposite directions, and minus represents the opposite direction. So we are done with the vector form of Coulomb's law, and if you have any doubt, do write in comment. In next video we'll be doing few more examples on this.